staticky audio from John?
Yeah.
Yes.
Yeah.
I don't know whether maybe repositioning the microphone or something. I didn't know if it was just me.
Let me see if I move this. Is that any different? I just moved the computer to a slightly different spot.
You're still too loud.
Sounds good on my connection.
It's a little louder, John. It's a little crackly, but it's loud. It's better.
Okay, let me turn mine down just a little bit. Okay. How's that?
What about you?
Okay.
Much better.
Okay. So the topics I'm going to cover will be
Hi, John.
Carol, John is muted.
Sorry, when I muted all, I muted you too. I apologize. You have to unmute yourself, so.
unmute. Oh, how's that? Okay. So what we're going to talk about is a little bit of the history of vaccines skepticism, the immune system, just very briefly, then the different kinds of vaccines that have been developed over the years, and then focus specifically on the COVID-19 vaccines and a kind of framework for looking at the ones that will be coming out. So it's good to keep in mind history. Viruses derived from the Latin word that means poison. No one's exactly sure why viruses, what the evolutionary purpose of viruses is, but probably it's to inject different bits of genetic material into living cells that allow them to mutate and might be evolutionary beneficial. If they're harmful, then they end up dying out. Now, in 1903, I won't go into the smallpox vaccination thing, but just realize in 1903, when there were vaccines already for tetanus and diphtheria, there were already anti-vaxxer organizations. And when it was suggested that there be a national health department created, people called it socialism. So it was defeated. In 1918, with the flu, there were anti-masker leagues and huge arguments in communities about how to deal with things. And so in 1952, although President Eisenhower was against big government, the Department of Health, Education, and Welfare was created because of polio. It had gradually increased to a peak of 52,000 cases that year. And it mostly hit kids, the middle and upper class families. Remember, the Reconstruction Home in Ithaca was a place where they had kids in iron lungs. And at that time, they had recommendations for all the kids to stay home, avoid playgrounds, stay home all summer. So these kind of restrictions and the people rebelling against them go way back in history. In fact, the same thing happened with the plague and smallpox, and governments have tried to cover things up ever since that there were pandemics. Now, we're going to talk about the immune system, and here's my non-copyrighted diagram in which we have something which is called the innate immune system, in which there are neutrophils and monocytes represented by N and M, and there are all these substances floating around that are called interferons. I drew them as an I, floating around, and some other substances, but like interleukins, that are non-specific and attacked an invader. Now, when we've gotten exposure to things over time, we develop in our B cells, which are studied with antibodies, and some of these antibodies are produced by the B cells and float around so they can attack some foreign invaders out in distance. And T cells, which also have those recognition sites on them, but don't secrete the antibodies, so that we have an early system and a later more specific system that takes a while to kick in for our immune system. Otherwise, we wouldn't survive as long as we do. Now, the B cells and the T cells have some other specific varieties, but we don't need to get into that. It turns out that kids don't have a lifetime of prior exposures, of course, so they don't really depend on their B cell and T cell responses so much like we as adults do that have contacted many things in our lifetime. So once they're weaned from their mom's breast milk, they have a more robust innate immune system response. So there's some evidence that that's one of the big reasons why kids under 10 are rarely getting ill, because when they get infected, they have a very robust innate immune system response, whereas it's really faded in us because we're depending more on our learned antibody and T cell responses. So that that in addition to the fact that as you get older, you have more comorbidities, makes you more vulnerable. Now, notice, why is it that when we get a cold, that it just doesn't weaken us, and we go on in a cascade of one event after another, get worse and worse, and die? Well, it's because the innate factors end up kicking in all of us, so that we're relatively protected from that kind of death spiral. So that you rarely see somebody get a cold, then they get another cold after it, then they get a worse one, then they get a pneumonia, and they die. Now, there's some people that have bad lungs and other conditions in which they do get a secondary infection, but we're largely protected by our innate immune response. Now, vaccines can induce the B cells to form antibodies and the T cells to also give you recognition. It turns out that the B cell antibodies ramp up over 1 to 2 weeks, and the T cell response also roughly over that period of time, unless you've got a bunch that are still around from a recent infection. But your antibodies gradually decay over 3 to 6 months. But you have some long-lasting recognition in your T cells, and it was only discovered about 20 years ago that some of the B cells have what are called memory cells, and those cells, if they're induced, end up still producing some of that same antibody against that invader in little bits for years afterwards. So it would be nice if we had a vaccine that gave us not just the short-lasting antibodies, but some that gave us good T cell and B memory cell remembrance. So it's hard to measure T cell function, though. So almost all the vaccines are based on measuring antibody levels, which, as you read in the newspaper about COVID antibodies, they're all declining after 3 to 6 months, and that's normal. It's hard to measure the T cell function, though. It's a difficult kind of assay, although people are doing that now to try and figure out which of these vaccines might be more helpful over time, but it's not easy to measure. Now, keep in mind that placebo recipients of, say, a flu shot or a COVID shot, that the placebo recipients only get infected about 10% of the time during the flu season. So trials of the flu shots generally only involve about 6,000 to 8,000 people only. And if you have a flu shot that's 50% protective, if you didn't get the flu shot, only about 10% of people get the flu in a given year on the average. And of the people that get the flu shot, about 5% of people. But of the people that didn't get the flu shot, 90% of them aren't going to get the flu anyway. And I'll come back to that when we talk about the COVID vaccine trials that are going on. So it turns out that different vaccines induce different types of responses. Now, probably all of you have smallpox vaccination scars on your arms, maybe not Cheryl. Did any of you ever get the smallpox in your life? None of you did. Why? Because it gave you long-lasting T cell and probably B memory cell protection for the rest of your life. So we'd like to have a vaccine that can do that. Now, it turns out that if your cells are presented with a whole array of different triggers, that is foreign particles, they're called antigens, your cells can see all those together and cross-link on them, and that gives you a T cell, long-lasting, and B memory cell kind of protection. That's the sort of thing that some vaccines, like a whole cell or smallpox, which is a weakened whole cell vaccine, could give you. The oral polio does that also. The FluMist, which is the spray for people that are under 50 and healthy. The problem with those whole cell vaccines is you need to inactivate the virus, and to do so safely might take a while, and there's a small risk that that whole virus, which is weakened by one of a couple different means, could revert to a fully active state. So that vaccine with a whole cell, good long-lasting immunity is really the ideal, but there's some risk to it, so that it takes a lot of safety testing for that to be able to be given to large populations. Now, it also turns out that luckily there are some vaccines in which the antigens and the particle end up self-associating in a kind of circular structure that's called a viral-like particle, and it's studded on the outside with antigens. It's difficult to make, but it turns out that the hepatitis B vaccine and the HPV for young people do form that kind of viral-like particle, and they seem to give you also lifelong protection. As far as we know, the HPV hasn't been around that long, but with the hepatitis B vaccine, they've tested people, and they see that even though their antibody levels have sometimes gone below the level of detection 10 years later, that no one that ever got the hepatitis B vaccine and responded, and 95% of the people did, but 5% didn't, but all the people, and you used to have to get an antibody test to show that you responded, all of those people, when exposed to hepatitis B in the future, never got hepatitis B again because they had long-lasting immunity, even though it couldn't be measured. So that's the ideal that we'd be looking for in a vaccine. Now, you can see that giving the whole cell inactivated vaccine would be ideal, but it's a little bit harder to make that. You've got to be careful about safety, about it reverting, so that in the 1970s, the flu shots that we got all got converted to a kind of broken up pieces of the virus outer coat called subunit kind of vaccines, except for the flu mist one that I mentioned, the inactivated spray, which was first on the market in 2003. So it's easier to make these other kind of vaccines, which were just naked viral particles, say like the outer coat of the COVID-19, the spike protein, or they can be grown from some recombinant technique in which you take viral DNA for the protein or the messenger RNA. These are ones used in the vaccines now, and you make your own cells to produce that kind of protein. Now, if you just are giving somebody, though, the naked protein itself, you'll get antibodies to form, or the subunits, which are broken out pieces, you'll get antibodies to form, but they'll fade after 3 to 6 months. That's what happens with the flu shots that adults have been getting for the past 50 years. One of the reasons why we have to keep getting a vaccine each year. However, it's also because the flu shot can mutate between years so that there might be slightly different strains. But that's not an ideal kind of vaccine. Now, Fauci and others have been trying, I think all his career, to try to create some flu vaccine that will work against many strains and give long-lasting protection, but it's never happened. And this, the people that work on vaccines might be able to explain why, but the answer is it can't be easy, but I don't know why. Now, the vaccines that cause us to actually make the protein, and that's the ones that are furthest along in the trials right now, that give you the messenger RNA and your own body makes the protein, so that you will be creating some antibodies against that spike protein, should be protective, but nobody knows yet that those kind of vaccines will cause you to make enough of that protein that you'll be able to coat the outside of your cells in a way that allow your immune system to cross-link against those antigens and give you the kind of long-lasting protection that we hope will happen. We'll come back to that. The different vaccines that are available come in several different types, based on some based on old availability of vaccines, and some are these new ones that have never been mass produced before. So the kind of ones that people are looking at are, you can take an inactivated whole cell vaccine, but as I said, there's some risk to that. You can inactivate it by various things, chemical means or heat inactivation, or just waiting until it passes through enough egg cells or something that it mutates, and it's tested to see that it's less pathogenic. But there's a risk to that, and it takes a while. It turns out that the Chinese are actually giving this. Are they testing it? I don't know. Nobody knows. There is a company that's already giving it. They're giving it to some of their military and other people. And hopefully they're doing some safety testing to figure it out, but it's a bit of a crapshoot. Nobody is gutsy enough in the United States to be trying that in wide trials right now. There are some companies that are working on it, though, and they'll probably end up testing it in countries that are poor and willing to take the risk. But that would be probably the best in theory. Now, a lot of clever different techniques. One, which is to take another virus, common adenovirus, and put the viral DNA or the RNA into it that makes this protein, the spike protein that we want to develop antibodies to, and introduce that in a shot so that the virus goes into our cells, and realize that viruses have no energy producing capacity of their own. They can only exist in a host with their own energy source, so that they might remain, on a cell surface, say, for a day or two, but they'll just degrade from sunlight or various other things. They can't maintain themselves without some other energy source so that they could reproduce for a while. But if you take then an adenovirus and cleverly introduce the viral DNA or RNA to make the spike protein, you can give that in a vaccine. An Ebola vaccine was made and approved and tended to give a strong response to it, but the outbreak faded before the protection could be confirmed. But that's the basis for the AstraZeneca Oxford University vaccine that's being worked on, and that's moved along fairly quickly because they'd already tested it out in that circumstance. What they had to do also was they had to take a chimpanzee adenovirus. I mean, there's a lot of trial and error to this, because if you give somebody a human adenovirus, we already have antibodies to that, and the virus wouldn't work. So they had to find a chimpanzee adenovirus that can't reproduce in humans, tag it to some viral DNA and RNA, and introduce it to our cells. And it looks like that'll probably work. Just in the last couple of days, you'll see some conflicting evidence about whether that works or not. It was by mistake they gave a half dose to the first 2,800 people in filling the vials. They just ended up filling them incorrectly, and that actually worked better than giving the whole dose for the first of 2 shots. People are still trying to figure that out, but it's likely that that was because the half dose was given only to people that were under 55, and they would probably have a better response. But that whole vaccine question, the AstraZeneca one, is promising but very muddied for right now. So there are other vaccine companies that are using a similar kind of mechanism. There's Johnson & Johnson, there's Merck, that's the Russian Sputnik V is already being given out. Putin has given it to one of his daughters. I don't know which one he chose or which one turned it down. But presumably they're also testing it for safety, and you'll see soon in the next couple of months, how well these vaccines are working. Keep in mind, though, that with a vaccine that you're giving to healthy people, the first order of business is it's got to be safe, because there are rarely vaccines that get people into more trouble. There was a dengue virus vaccine that came out 20 or 30 years ago, and the people that had the vaccine, when they actually got exposed to the disease, actually did worse. So that was taken off the market. We didn't see it in the United States, but it was done in other countries. There was also a rotavirus vaccine that caused kids to get more problems with their bowels. And then there was a respiratory syncytial virus vaccine that was developed about 30 years ago. They gave it to about 21 people to begin with. They got pretty sick and 2 kids died out of the 21. They still don't know exactly why, but actually that experience has caused people to lead to some of the recent vaccines. So it's not a given that the vaccine will make things better. Note, though, that the ones that are the adenovirus vehicle ones, that's the AstraZeneca and some other ones, they're expected to supply about 1/3 of the total world doses because they've been ramped up, able to be ramped up more quickly because they had a vaccine for Ebola that they'd shown, how to make it. So we'll probably be seeing mostly that vaccine. The advantage of that being also it can be stored in a refrigerator. It can be kept at room temperature for a while in somebody's offices. And some of these other fancier vaccines, the new ones with which we'll come to, have to be kept very cold, and it's going to be very hard to distribute them. So another way that you can give a vaccine is just to take the naked protein, like I mentioned, or just take the DNA and inject that, or some kind of protein subunit from the outside coat of the virus. And you have to be careful with this because it looks like if you develop antibodies to the spike protein of COVID, that you get good protection. We don't know how long-lasting that is, but some of the vaccines are not targeting the spike protein, but they're targeting internal proteins of the virus. Nobody knows whether that's going to be helpful or not, but there's over 100 companies that are testing different variations of the vaccine, so we're going to have to be watching carefully. And some are targeting what's called the receptor binding domain, which is the spike protein plus part of the surrounding membrane. I don't know how they figure out exactly what part they've got, but there's going to be some differences amongst the vaccines that come out about exactly how they're made. There's a couple companies working on that as well. The pros about that is if you just take the spike protein, it worked against SARS when it was tested in monkeys, but it wasn't tested in people. It's easy to manufacture because you're just taking subunits and pieces that they can easily get nowadays. The problem with it is you're probably just going to get a short-acting response to it for the reasons that I mentioned. And also, in order for that to be very immunogenic, you have to add something else, kind of lipids, or they're called adjuvants, to boost response, and you need to take multiple doses of it. But they're probably going to be developed a long time also. Then you can also just take the naked DNA or the RNA of the virus that causes our cells to make the protein, and you can coat it with a lipid envelope that allows it not to be quickly degraded as it enters our body and it gets uptake by our cells. And that's what the Moderna and the Pfizer vaccines that are furthest along are doing. Nobody's ever done this in a vaccine before to see whether it works as well as the theory does. The Moderna ones codes against the spike protein. The Pfizer one codes against the receptor binding domain. could be some differences, but they both, as you'll have heard, seem to give good antibody responses at about 95% of people that have been given them so far. They're easy to develop. That's why they were the first to finish the trials. They may mimic the natural infection if they cause their bodies to make enough of that protein to cause cross-linking in a way that stimulates our T cells and B memory cells. At the very least, they'll probably give us pretty good protection for somewhere between 3 to 6 months. Nobody knows if they give you long-lasting protection, or if they work as well in all subsets of people. When they are being approved, because everything is so urgent, they're only requiring about 180 cases of infection among 30,000 volunteers in order for a vaccine to be approved. That's only about 1 out of every 150 people that got the vaccine. So there'll be a lot more information that will be coming as more people get sick, but the early results are probably predictive that we're going to have good acting response, at least for a number of months. The cons against that is that if they're using a DNA, which neither of these are, they're using messenger RNA. If you're using a DNA, then it requires your own cells to be dividing before they'll produce the protein. But neither of these seem to be that type. And as I mentioned, they have to be stored at a very low temperature. The Pfizer has to be stored at minus 70 degrees centigrade. There are refrigerators like that, special refrigerators. And knowing this back around April or so, the government was working to see that there were warehouses set up with refrigerators that were able to do that in case they were needed. The Moderna one can just be in a regular refrigerator, minus 4 degrees centigrade. So that one will be more likely to be widely distributed throughout the country, whereas the Pfizer one will probably go to the big cities. It turns out that the hospital here does have a refrigerator that goes down to minus 70, and they can store 12,000 samples of vaccine. We'll see how that rolls out, but you'd be a lot in the news about this, about the practicality of trying to roll all this out. Now, there are, again, as I mentioned, possibly viral-like particles that you could make with the spike protein around the outside. There are about 5 companies that are working on that, but none of them are near trial endpoints. It's difficult to make them. It's safe, and it's likely to give a long-lasting response, but it's tricky because I don't think they know for sure how the vaccines, the hepatitis B vaccine and the HPV, actually was so lucky as to form these kind of particles on their own. So in the short term, most of them are likely to work, or they wouldn't be approved. But 95% response is obviously better than the 50% response that the FDA is requiring for them to be approved. And keep in mind that if one has a 50% likely response, that's really plus or minus 20%, given the small numbers of people, like 180 cases, for you to determine whether they're actually that good or not. So none of them are going to be 100%, so you can't assume that you'll be protected. there are antibody tests that you can get to see whether you have antibodies to the virus. They're really not recommended to be done routinely, though, because number one, the antibody tests might measure antibody to the spike protein, but they might measure antibodies to something else, which the company happened to say, oh, look, we've got this test, we can measure an antibody to an internal protein. That's probably protective, isn't it? So you have to be aware of the antibody test accuracy. And secondly, nobody knows what level of antibody response is going to be protective. That'll all be being looked at, or how long it will last. So all this will be studied with great intensity. So if I had to say, oh, what should you get for a vaccine? The first one that comes out that you're eligible for is probably the one to take, because we don't know when the other one's going to be coming around, as long as they seem to be safe. And luckily, the ones that are rolling out first seem to have only minor side effects for a day or so. More information will be coming. That to take the first one that comes out that seems to be safe and hopefully 90+% effective, you should take. We don't know whether they're going to work in the long term. You probably should not hold out to wait for the inactivated whole virus vaccine, or you might need to go to China to get it, because it'll take a while to see whether that's safe. The next most likely to be helpful are the ones that form viral-like particles, but none of them are close to manufacture yet. After that, I would say it's a tie between the ones that are the viral vector with the adenovector, that's the AstraZeneca one, or the Johnson & Johnson, which is further behind, or the Moderna or Pfizer ones. In theory, they could give you long-lasting protection, but nobody will know that for 6 months to a year. Now, and lastly, Novavax and several other companies are working on the subunit ones. I'm really not a fan of those because they're not going to give you long-lasting protection, almost certainly. But if it's the only thing that's available and they're safe, and there's a shortage of other ones, that would be fine for the short term. So realize that with the flu shots, again, each year they only test about 3,000 to 6,000 people, because they know that these have been produced in the past and that they've been pretty safe. These new vaccines are going to be tested in 30,000 to 40,000 plus people. So it's going to take a while to see whether they are as safe. It's going to take a while to see whether they work in immune suppressed people, people over 65, people of different races. So far, it looks like the Moderna and Pfizer ones, in the small numbers that have been done, look to be as effective in people over 65 as under, but the numbers are very small. And it'll take a while to figure that out. The groups that are going to decide this is not just the FDA, which is being lobbied by Trump today to try and push it out, but there are several independent groups, including the New York State Health Department, but also the American Group on Immunization Practices and others that are looking to see if these do make scientific rigor. So I think it'll be well supported when they are okayed. Thinking ahead, maybe this would answer a question or two ahead of time. What about giving the vaccines to people that have already had COVID? Nobody knows whether that would be helpful or not. The common coronaviruses, of which there are 4, seem to give only protection for about a year or so. Whether that's true or not, I'm not convinced, because I don't think that people have really bothered to study it in any detail. But one of the reasons why kids are relatively protected is they have their innate response, which is more vigorous than ours, but also they get colds all the time. So they get coronaviruses and pass them back and forth as they're young. So they have some partial protection. And when you look at populations of people whose blood was stored from 5 years ago around the world, they found anywhere from 20 to 50% of people have some antibodies to coronaviruses already. That's one reason why parents of young kids may actually be protected, and that's going to be looked at also. So we don't know whether the vaccines are going to help or be necessary for people that have already had COVID, whether they're going to get a good long-lasting immunity from a natural case of it or not. And what about revaccinating people when a, quotes, better vaccine comes out? Again, nobody knows, but keep in mind that it could even be that with the first vaccine, you'll form antibodies, so that the second vaccine you will actually not be helped by or maybe be harmed by, because you already have some immunity to it and your response may be too vigorous. So there's a lot still to be learned. There'll be many people looking at this. There are people looking at the long-term T-cell response, and tomorrow we'll know more, 6 months we'll know more, and a year from now we'll know more. So I'm glad to answer any other questions. Robin says, if you get the vaccine and still become infected, would you likely have a less severe infection? Right now, it looks like from the preliminary results of the Moderna one, that of the people that didn't get the vaccine, that got the placebo, 185 got sick. Of the people that got the vaccine, 11 got sick. That's 94.1 protection, and none of the ones that had the vaccine had severe infection, but the numbers are too small. It's very optimistic, though.
Thank you.
Can't hear you, Marcia.
The question is, after safe time after getting vaccinated, would it be safe to travel?
Yeah, no.
Oh.
I mean, you'd be taking a small risk because remember, 94 or 95% protection is not 100%. There will be some push to get people's antibodies tested, and hopefully with an accurate antibody test, as I mentioned. And if you do have a good level of antibodies, which remains to be determined, then you're probably well protected for at least 3 months, maybe 6 months,
travel window,
maybe longer. But in the meantime, unless we have some evidence for that, you'd tell people to still wear masks and do distancing until there is thought to be enough, quotes, herd immunity or long-lasting immunity from the vaccines that you can travel more widely. Now, having said that, there is pretty good evidence that if you travel now by plane, that it's pretty safe. The planes aren't very full. If you go on one of the airlines that is keeping seats empty and you travel on a day that isn't busy and everybody wears masks, that you're likely to be okay, but there is a small risk to it.
Small risk.
And at Leckman's too. Actually, this is the first I've heard about the herd immunity.
Oops, can't hear you, Jerry.
Everything you've said is absolutely clear, and I agree with you totally. And I was commenting to Barbara that this is the first I thought about or hearing about the need for herd immunity to be established after the vaccines.
It's hopeful, but we really won't know until 6 months from now and a year from now. They'll be studying the people that got the vaccines to see if they get sick again.
Of course,
We don't know.
there's already evidence that people can get
Yeah.
reinfected. So, of course, people get reinfected with flu too.
Yeah, there are a few, but they're rare cases of people that have been reinfected already. And the very few, it's mostly, and again, these are very few, like 4 or 10 or 12 around the world. They've had a slightly different strain of the virus. Like 3 out of 4 has been mild, or they didn't even recognize it. They just had to get retested because they were flying. One person was sicker instead, so it's too early to tell, but it looks like once you've had the virus, you're probably well protected for 6 months, maybe more. We'll see. And keep in mind, if you're one of those people that has a mild illness and you're over 65, there are some treatments you can get, including you can be given some antibodies by vein that decrease your chances of getting into the hospital by a little bit, down from around 10% to about 3%. But it's possible that if you get those antibodies, you won't develop antibodies of your own also. And so Trump may be at risk of reinfection. Nobody knows.
We can be hopeful.
So we have we have 3 questions after Jim Quest in the
I
chat.
understand that they.
Let's see. Let's see. One vaccine. Does the second one need to be from the same company? Oh, that's a good question. I don't know. There'll be some recommendations about that, but I don't know. It would make sense to get it from the same company, though. But who knows?
Go ahead, Jim.
I understand they pick strains in advance to test the flu vaccines. Are there strains of this COVID-19 that they have picked, and how do they choose which ones this is going to work against? I understand there are thousands of strains.
There are. They've found about 12,000 mutations so far. And they don't seem to be that one is more infectious than another. There might be one that's more transmissible, but not necessarily more severe, and that one has come to predominate around the world. But it doesn't seem to make a difference. As far as they can tell, the spike protein is still the basic spike protein, so they'll be trying to target the spike protein unless something changes.
Thank you.
One of the questions in the chat is, what are the age 65 plus sample size for the Pfizer and the Moderna trials?
Oh, I don't know what the sample size is, but again, with the Moderna, which is probably going to get improved the next week or two, there were people that got the vaccine. There were only 11 people that even got infected. So the number of people that are over 65 is, probably in the several thousands, but it's going to be a couple more months before we know enough numbers to be confident.
Another very large question that's in the chat that I believe everyone is probably wondering about is pre or post vaccination. Can I safely see someone who has already had and recovered from COVID?
Oh,
That's
yeah, I mean, yeah, you should be able to if they had what's called a moderate to severe case, where you would expect them to have good antibodies. Of people that have been infected, they don't seem to be able to transmit active virus beyond 10 days past the onset of symptoms. And it's mainly in the first 5 days afterwards. You read about that now in the paper. They're trying to maybe cut down the time of isolation from 10 days afterwards to even 5 days, because when investigated, only 1 of 5 people actually follow the isolation for 10 days that they're supposed to. So if somebody has recovered, they're probably protected, again, at least for a number of months and hopefully forever. But it makes you nervous to go around without a mask on anyway. So that's one of the good questions. I don't think we can say, except that it probably would be safe.
Joanne?
My question sort of follows that. What realistically, okay, given that it's going to take time to, first of all, figure out, I guess today the government is trying to, I don't know if it's the CDC or the FDA is trying to figure out who will be given the vaccines first, right? Obviously, it's going to be healthcare people first, but then how is it going to work? Given all of the steps that have to be followed, the fact that we don't even have the vaccines out there quite yet, realistically, what are we talking about in terms of being able to walk around without masks, or getting together with larger groups of people, or maybe even with small groups of people? Are we talking 6 months? Are we talking about a year? Are we talking about a year and a half? I know this is speculation, but I'm wondering what, given the stuff that you've been reading and looking at, what do you think?
Well, 6 months from now, we'll probably know much better whether it'll be 6 months or 12 months or 15 months, but we won't really know until then.
In previous, for previous vaccines where, there was a sequence of, who would, get it, the priority. Was there, in a case where, for example, you would have somebody at high risk living alone with a caregiver, was the caregiver categorized with the high risk to protect that person, or considered a lower risk?
They should be a high risk. That's why all the staff at nursing homes are going to be among the priority people, and people that have to go into nursing homes. There was a question up there for a moment. I forget what it was. Could you flash it up again, Cheryl? Something about immunity.
It says, did you imply that a person who was asymptomatic would mount an immune response?
It's unclear. It looks like many people that are asymptomatic do mount an immune response, but not everybody. So that's a question that has to be answered. It's not clear, and some people get just as good an immune response and other people don't.
John, quick question. Am I correct that in the trials, they only tested people who, quote unquote, got sick? In other words, they were exhibiting symptoms. So does that mean they didn't catch the asymptomatic ones?
I believe that's true. My sister and brother-in-law actually have taken the Pfizer vaccine around Cincinnati, and she sent me their protocol. They give them a shot, and they come back in 3 weeks, and they give them another shot, and they do a nasal swab each time. After that, they come back and they get blood work, but they get no more swabs unless they are symptomatic. So we don't know about the asymptomatic cases yet. Now, there may be other protocols for the other vaccines that are going to be swabbing people routinely, but I don't know that. That's a very good question.
So the 95% efficacy, or whatever the word is, it really could be much lower than that if they're not catching asymptomatic. Is that correct?
That's correct. That's
And
correct.
would it be would
That's
it also be true
exactly.
that even though the asymptomatic people might carry a lower level of virus load, the fact that you catching it from someone who's asymptomatic doesn't mean that you would have necessarily a lesser reaction? You could get really sick catching it from an asymptomatic. Is that right?
Yes. In fact, the asymptomatic people seem to have just as much viral load on the average as the people that are sicker. So they apparently, they don't get as sick for the different reasons that we said. They're younger, or maybe they've got young kids. They've got some preformed antibodies from other coronavirus exposures from their kids, or reasons yet to be determined. So we don't know, but that's a potential hole in the vaccine trials, which maybe some of the other ones are going to fix.
I mean, I don't get that. I was an English major. If I can come up with that question.
Yes.
Why did
I was very dismayed. I was very dismayed to see the protocol that the Pfizer vaccine was using.
Hey, that actually is worrisome.
Yeah. That's one good reason to keep using masks even around people that have been vaccinated, though. It's good that you bring up that point, because they could be asymptomatically infected. Looks like it'll protect you very well from getting sick. And the very few cases that have been seen among the vaccines, none of them have been severely sick, but it's early days, and it looks like it'll be good, very good short-term protection, but you might be able to spread it asymptomatically. That's right.
The people that participated in the trial, were they told to go about their life like they had been? I mean, we don't know how many of them were practicing good preventive measures before and even during. Depending on where they live, they might not have been. Yeah, we don't know, maybe they weren't catching it because they were continuing to wear masks and social distance.
Yeah, but there were thousands and
How do
thousands.
we really judge how effective the vaccine was?
True.
Yeah. Now, keep in mind, the people that are taking it are generally people that are going to be more careful. But they're giving it to 30,000 people, and they're also giving it in Brazil, they're giving it in Turkey, they're giving it in China, they're, not necessarily China, but giving it in India. I mean, they're giving it to other places, and they're giving it, they tried to pick places that were hotspots, or they thought were going to be hotspots around big cities, etc. So they were trying to give it to people that would be exposed to some extent. But you're right, so far, the Moderna, I calculated, it's only 1 out of every 150 people that have gotten the vaccine have even gotten infected so far. So there's a lot still to be learned. And as the trials continue, the people that got the vaccine, it depends on which one that you're signed up for, but if it's approved and you're in a group that's supposed to get it, like a healthcare worker, or you're over 65, you should be able to get the vaccine. They then won't be able to study your group as well because you've now gotten the whole vaccine, but they'll continue to study the other groups, the people that were at lesser risk. They will accumulate more information. It just won't be as much information. And keep in mind, there are over 100 candidate vaccines that are geared up. Only 11 of them are in any reasonable number of trials so far. So there's a lot more information to be gathered.
So in that same vein, let's say, I get the vaccine, and because it's still the first several months and not a lot of people have it, or not everybody's been able to get it. So I'm going to continue to wear a mask and do all those things. So again, how will I know whether it's the vaccine protecting me or my own practices?
Yeah, you won't.
One has to realize about vaccines is that very few vaccines out there actually are designed to prevent infection. What they're designed to do is to prevent clinical disease. So if you look at the vaccines we routinely give kids out there, measles, mumps, rubella, there's a lot of kids who probably got exposed to measles, but you don't see it because the immune system shut it off frequently. So it may well be that in the long run, in terms of these vaccines, the asymptomatic infections may be largely irrelevant. If
you can get enough people.
If the population is vaccinated to a sufficient degree. The warp speed people are estimating there will be enough vaccine in the United States by June to vaccinate everybody. The problem is going to be the 50% of the idiots out there who are going to decide not to take the vaccine.
Yeah, and going back in history, as I mentioned at the beginning, throughout history, there have always been people that are anti-mask, anti-vaccination, governments that cover things up. Nothing has changed among people in history.
We have one comment question in the chat that says, I haven't seen anti-vaccine arguments replying these COVID vaccines, but are there indications that there will be an aggressive resistance to taking the vaccine from people previously exposed to it?
I don't know. You keep seeing these surveys, and more people seem to be accepting of the vaccines, but it's going to take a lot of effort, a lot of education, becoming the norm. It'll take a while. And people are working on what kind of messages to be sending out also. And people have realized from all the anti-vaxxer groups that are out there that, and I don't remember the different arguments to be using, but there are people that are gearing up to try and get people to listen to reason.
Good luck with that.
Yeah.
John, you might have answered this, and I'm just not extrapolating from what you said. But if the virus mutates, will the vaccine be the vaccine, whatever we got, be irrelevant?
Probably not, but we don't know. I mean, there's already been at least 12,000 mutations that have been detected, and they don't seem to be really affecting the transmissibility particularly. I mean, the transmissibility, that one is a bit more transmissible, that is taken over the world, but it doesn't seem to be any more virulent. So, not that we would expect, but keep in mind, this is all good practice for the next pandemic that comes along, because there's always going to be mutations in viruses, and the one that's been most feared has been the flu, which hasn't yet hit, but it's only a matter of time that it's going to occur.
And on that happy note, we should all have ice cream. And cake the rest of the afternoon.
I think we need to have a support group after all of this.
So John, are you willing to do updates on this as things come along? Especially when will we know? I mean, I realize you may not know the answer, but what will be available in Ithaca? And is it likely to be through the pharmacies or through your doctor's office or at the hospital? I mean, do you have any guesses on that?
No, I don't have a guess. It's all being looked at nationwide, statewide, and countywide. But the health department here and health departments around the country are all part of the planning.
There is another question in the chat is, do Pfizer and Moderna websites post details about their trials, sampling, results, and all that?
I don't know. I didn't look up the Moderna site. I would think so, that they're trying to be very transparent, but I did not check out each one, but give it a try. But I think, again, we'll have to kind of take, whatever one is safe that comes out first and is available for people over 65 will be reasonable to get. 6 months from now, we might say, gee, I wish I'd taken that other one, but I don't think you can predict that.
Yeah. Is it going to be similar to like the shingle shot that you can really have a reaction? Did they indicate that on the trials?
Yeah, they've got enough people, they've vaccinated 30,000 people roughly. So they're just seeing for a day or so, people have headaches or achy generally, or a little bit of a chill. My brother-in-law, he probably got the real vaccine with the first shot. That's how he felt for a day. With the second shot, he didn't have any side effect. My sister didn't have anything to either one. So, but they're not seeing anything more than that. With the Moderna and the Pfizer ones. Remember the AstraZeneca, they had to interrupt the trial twice because of some neurologic problems that were thought not to be related, but, more information to come out. Yeah, I'll be glad to do it again, and whether it's 1 month or 2 months from now when we know enough different, we'll see.
Well, thank you. Thank you very much.
Thank you.
Sure.
Thank you.
Yeah, thanks, John.
Yep, good.
And John
All
is
right,
involved in the Love Living at Home play reading group. If anybody wants to read a play along with John and several other members, you should, touch base with either Cheryl or keep an eye out on the emails that you get from Love Living at Home. How's that for a change of topic? But since it's John involved in both, I thought it was appropriate.
And that reminds me, yeah, I ordered some of the scripts. They only had 2 from the publisher, so I can make some copies, but I'll be communicating with you. I asked him to try and track him down some other place, but we might have to switch topics. We've got until January.